In this session, I will be introducing a few useful comments for exploring and preparing data. We are still going to use session 2's in-class example so that you don't have to spend time familiarize yourself with a new dataset, but you will be using a new data for this session's practice exercise. So once I successfully load the data, you will see several variables that appears in the variable window. So the first useful comment that you can use to help yourself get to know the data is called describe. So if you simply type describe, enter, you will see that it usually tells us, for example, the number of observations, the number of variables, and also it lists the variable name and the type of the variable. Sometimes the variables also have some label indicated, more descriptions in addition to the variable name. If so, it will also be listed for you. So an abbreviation of the comment describe is DES. So if you type and enter that, it will give you the same result. Basically, this is just to show you, give you an overview of your new data set and to let you know, for example, how many observations or how many variables that you will be working with and the type of the variables. So the second useful comment to help you get to know the data is a list. So this list variable, you can either just use list by itself, or you can just ask Stata to list a specific variable. For example, now I'm just going to first try list and enter. So if you do that, I have 30 observations and it's gonna actually list all 30 observations by its variable name and its basically its values. So we have some qualitative data, female, male. We have some quantitative data, age of 30, 19, 26, and so on. Sometimes you may also only want the data to list, for example, one variable, let's say list SAT. And if you click enter, it will list that variable into your result window. This is sometimes not super useful because you can just simply go to the window browser and look at the data yourself. This can be useful whenever you want to include the list of your observations into the result window and therefore stored into the log file so that you can share that with others. On the other hand, usually you will be working with some relatively larger data set. And if you just do list, you'll probably have a very long result shown. So another very useful thing, just to give an idea of what are the variables, you can just show, for example, the first 10 observations. So 1/10 in Stata is always means from 1 to 10. So if you do list, for example, list age in 1 to 10, it will only list the first 10 observations for you. So maybe you could sometimes list the first 10 observations that you have without indicating a variable, and just to give your reader an idea on the data that you are working on and some example observations. So the next comment that is useful is count. In this one, you cannot specify a variable. So the only thing you can do is just to type count and enter. And this will show a number for you. Basically, it always helps you to count the observation needed. This count comment will be very useful when it's coupled with the if statement. So if you want to count some variable that meets some criteria expressed in the if statement and see how many observations are there. So that's when we use that. But in general, when you just type count, it will give you the number of observations, usually the highest number of observations. Some variables might have missing observations. And the last one is something that you are familiar with. This summarize or sum comment is basically the most common and useful one for getting to know your data, and this is the one that gives you the necessary descriptive statistic. Right? For example, you can do sum, and it will sum all the variables. However, observe that whenever it's a qualitative variable, it's not a numerical term. It will not calculate the mean, standard deviation, mean or max for you. Right? Alternatively, you can also do sum age detail, if you recall from the previous sessions. So these are some of the useful comments for you. Every time you load a new data, these are some things that you want to use to get familiar with the whole data set and a specific variable of interest. So the next thing that I want to introduce is really about the Stata operators and its expressions. The first comment is this display comment. Although it has more functions, but the only function that I want to introduce for now is basically Stata can work as a calculator using this display comment. So whenever you want to use Stata as a calculator, you have used display, for example, 2 plus 3, and it will display 5 for you. So the abbreviation for this comment is this. So 2 plus 3, that's the same comment. Sometimes we can also even abbreviate it into DI. So DI 2 plus 3, that is also the display comment. Okay, so you can utilize other arithmetic operators to calculate other things that you want. For example, display 2 multiplied by 3, display 2 over 3, display, for example, 2 to the power of 3, that is 8, or you can also do display, whenever you want to do the square root, that is SQRT, the square root of 2, that is 1.414, or you can also ask it to calculate, for example, the log of 2. Okay, so this is where you can use the display to treat Stata as a calculator, if you'd like. Of course, you can also use it to calculate some more longer calculations, right? For example, you want to calculate the log of 2 divided by the log of 3 plus 10, and so on and so forth. So it follows all the arithmetic rules. You just need to type it correctly. Okay. More importantly, Stata is a lot more powerful in terms of using its logical and relational operators. And this is where we can make use of the if statement to talk about the logic and to talk about the relation. So I'm going to first introduce this count comment with if statement. So for example, we could maybe utilize the variable age. We know that there are a total of 30 observations, but what if I want to know the number of observations for age that is above 20? So previously I did age, that's 30 observations, but if I do count, if age is greater than 20, then if I click enter, it will show me that 18 observations. So 18 individuals has an age that's above 20. So this is greater, less than, greater, or equal. So if you want to look at age above 20 inclusive, that's just a count if age greater, equal to 20. Now we have 20 observations. So basically we have 2 observations that has an exact age of 20. Okay. If you want to use the if statement for equal, for example, you want to know the number of observations that is exactly equal to 20, a double equal sign is needed, which is used for equality testing. So you will have to do count if age equal 20. So double equal sign is always used after the if statement. So now if I click enter, it's going to be 2. Okay. Also, if you want to use this not equal, so basically what you need this is basically count if age is not equal to 20. So then that should be 28 observations, because 2 has an age of 20, then 28 has an age that is not 20. So this is not equal sign here. Alternatively, more importantly, you could basically use the and or logic. So for example, if I want to count if age is greater than 20, and this is the and symbol, and also age is less than 30. So if I click enter, that will give me 7. Okay, so think about whenever you can use and or whenever you can use or, right? So if you use or, so I want to include, for example, anyone that is greater than 30. So for example, greater than 30 and less than 20. If I use and, no one is going to be above 30 and at the same time less than 20, right? So if I enter that, it's going to be 0, right? No one qualifies for that. So this is actually an expression that does not make sense. This is where you want to look at any individual who is above 30 or who is less than 20. So you want to use this or symbol. Click enter. We have 17 individuals who qualify for this if statement. If statement. Okay. So I guess using operators. So first of all, understand we sometimes must use operator symbols for words such as or and equal. So the symbols are summarized in these slides: and, or, greater than, less than, equal, or not equal. Okay. And second of all, it's sometimes a little bit easy to confuse, but we do have single equal and double equal sign here in Stata. We use single whenever we are defining a variable. We are going to create some variable later, and we're going to define how we want to create the variable. We're going to use a single equal. Using double equal, this is where we want to test a qualification. So it's usually used after the if statement. Only if this variable equals to 20, only if this is true, we're going to count this. So we're really testing for an qualification there. That's where we use the double equal sign. Okay. So another thing is sometimes if you want to use this if variable, but you are using it for qualitative variables, which is non-numeric variables, and the data it has is in the text form. What you need to do is basically, for example, previously you just wanted to count if age equals to 20. It's a numeric form. You enter and it will easily count for you. But suppose now if you want to count the number of observations that is female, or the number of individuals that is from the US, right? You need to, because these are non-numeric form, you want to use the double quotation here. So you want to do count if country equal you cannot write US like this. Is it capital term? Okay. Instead, if you do that and enter, it will show you that it's not found. But instead, if you use a quotation term, because you're basically telling Stata that I'm asking the country to be the same as a text that is US. You click enter, it will count that there are 20 individuals from the US. You could also count if gender is female. It's case sensitive, so I want to know, okay. So female. We have 15 individuals that are female. Okay, so be a little bit careful with these 3 additional tips. Additionally, it is also very useful to sometimes not only sum the whole variable, but to use the sum our descriptive statistic with the if statement, right? So this is very useful. For example, sometimes I want to say, for example, I want to sum age, and this gives me the descriptive statistic for the whole data. But alternatively, I can say I want to know the average age for female. So sum age if gender equals female. Don't forget about the double quotation if it's a text, if it's a qualitative variable. So enter. The average age for female is 23 years old. And alternatively, the average age for male is actually a little bit older, it's 27. This is very useful when sometimes you want to look at, for example, the age across different groups, the GDP across different countries, any numerical variable across different categorical variables. So sum plus the if statement can be very helpful. Alternatively, you could also, for example, sum, say, SAT by gender. Or you can also say, I want to sum the SAT if age is less than 25, to see if younger individuals has a higher SAT score. So it's about 1856. Or if I want to sum SAT if age is above and equal to 25. So the SAT score is a little bit lower, but there's no much difference. It's only 1841. Okay. Actually, we have another variable, which is the newspaper readership, which is times per week. So you could say we have several numerical values here. So it's 5, 6, or 7. The lowest is about 3. Okay. Sometimes if you don't have so many values, you could also tab a quantitative information. So tab, because this variable is really long, so instead of typing it, I'm just going to double click it from the variable window. Double click, tab. So it has 3, 4, 5, 6, 7. So now what if I want to sum the SAT score if this newspaper readership equals to 4. So this is a numerical value. You don't have to give the equal sign. Okay, so equals to 4. So the average score is 1822. But what about a high frequency of reading the newspaper? 7 or maybe 6. So the score is higher, right? And it could be even higher for readership, that is 7 times per week, 1885, right? So actually you see some positive relationship between this newspaper readership and the SAT score. But of course, you see some positive correlation, but we still want to test whether that is something that is statistically significant and so on. Okay, so this is the make use of if statement. Usually we can use basically with any comments. But for now, for what I've introduced, COUNTIF and SUMIF are something that's useful for you. And remember several tips. The next useful variable comments that I want to introduce is to create new variables. And whenever we want to create new variables, the Stata code is called generate. You want to generate a new variable, right? So I probably don't have many good examples here, so I'll just make up some. So for example, if I say now the SAT score is something above 1,000, and I want to say use a unit that is 1,000 score. So I can probably create a new variable that's generate SAT by 1,000. You can, so basically after generate, the first thing you type is the name of the new variable. So basically the generate or gen, you type the new variable name. You can name it however you want it, but be informative. And then equal, see this is a single equal sign because you are defining it, right? So equal to an expression that you want. So for example, now I want to generate a new SAT score where the unit is 1,000 score. So then the expression is that it is equals to SAT divided by 1,000. So I click enter, and actually in the variable window, you see a new variable generated for you. But you can also double check in the browser. So everything is divided by 1,000. You created a new variable that is called SAT by 1,000. So whenever you have some unit conversion, you can always use this to generate a new variable. Okay. We can also, for example, say, suppose there's any incentive program, and say the newspaper readership has been doubled for all the individual students. I could generate, I'm just going to type gen because that's the abbreviation. So gen new readership, that is the previous readership doubled. So the previous variable multiplied by 2. It's always one single equal sign, and then the old variable by 2 because I defined the variable to have a doubled readership. So click enter, and I check the new variable is successfully created. One more, basically sometimes we may want to look at the nonlinear effect of age. So very often we create age square variable. So generate new variable that is called age square and equals to age. There are two ways you can express this. One thing is age square, which is like this. Another way you can do that is age multiplied by age. So you get the same result. So now I'm going to click enter. So I created another variable that is called age square. Age square. Sometimes we use some quadratic terms for non-linear relationship. But the first step to do that is to create a new variable. Okay. So basically, this is the generate comment. The new variable represents a new variable name, and sometimes you can also use the if comment. Sometimes we may want to use the if comment for some criteria or just to exclude some missing values and so on. And some common operators still can be used in the equation, plus, minus, divisions, and multiplications, and so on and so forth. The next thing that I want to cover is this generate variable is also very, very useful in terms of creating binary variables. Binary variables are the variables that has only two values, 0 and 1. Sometimes you want to deal with continuous variables. Sometimes you only want to know whether the two groups makes a difference or not. For example, female, male, or sometimes having a high frequency of newspaper readership or not having a new frequent readership and so on. So you could actually translate your continuous variable into a binary variable. It can be very useful. And this is where we can combine the if comment. I have some examples for you, but I do not have the data set for each variable. But still, I think it's always good that you pause the video sometimes and then take a look at my slides, right? As you see, we could actually create some new variables with some if criteria followed. So for example, what if now I want to create, I'm actually going to show you how this if variable works with creating a binary variable, but I'm also going to show you something that is even easier with what's offered in this text box. So now if I want to create a variable that has a high SAT score, I'm going to say generate SAT or high SAT equals to 1 if SAT is greater and equal to 1800. So this is where you are creating, generating a new variable or a binary variable coupled with the if statement. So if the variable fulfills this if statement, it will have a value of 0. So if you click enter, you're going to see that actually 14 missing values generated. This means that 14 observations does not fulfill this if qualification. So actually, if you take a look at this data editor, you see that a new variable that's called high SAT is created. So all the SAT scores that was above 1800 has a value of 1, right? But like I said, the way that this textbook or this information provided using the if combined with generate, it will create many missing variables, right? Instead of having 1 and 0, it actually indicates 0 and missing, right? And missing values. So actually, I'm going to introduce another way that I usually use, sometimes not introduced in the traditional textbook or some Stata resource documents. You don't have to use the if statement. You can directly generate a new variable that is called, for example, gen high score, and directly say it equals to SAT bigger, greater 1800. So you put that criteria into a parenthesis and let this equal sign to define the criteria. So if you click enter, it will actually not create any missing values. And if you take a look at this high score, basically we successfully generated a binary variable where if it's higher than 1800, it's 1, and if it's lower than 1800, it's actually 0. So that's how we can use the generate to create some binary variables. Alternatively, you could generate a low score that is equals to SAT, say, below or equal 1600. Enter. So always check if you successfully created the variable. We don't have many low scores, but still a dummy variable of low score is successfully created for you. Okay. So I'm going to continue to introduce some additional ones combined with that works well with this generate comment. One is called Recode. Recode. This is also very useful when you want to recategorize your continuous variables or just create a binary variable. For example, previously we talked about creating a binary variable that is called high score, right? So I talked about you could just use one line of comments to create this one line of comments to create a binary variable that is called high score, and the criteria is 1800. Alternatively, sometimes students find it hard to understand or remember this. Alternatively, you could do the recode comment. So the first thing you need is to create a variable that is exactly the one as the original one, but later on you're going to recode that new variable. You don't want to directly recode an original variable because that sometimes will mess up with your data, right? So now I'm going to create a new variable that's called high score 2. That is exactly equal to the SAT. Okay, so if you look at that, I just used the generate comment. So it's an SAT score. But since I already have the original score, I can work with these variables and recode these variables however I want. If I made a mistake, I can probably just delete it later. Okay, so what I do is basically you are going to recode and indicate the variable name, and however you want to let the old values to be replaced with the new value. You can do as much as you want, and then you can group them into the parentheses. So if you are creating a dummy variable, you only have some old values that becomes 0 and some other old values that becomes 1, right? So this is how you could then recode high score 2. And then a space, and then I'm going to I don't know my lowest SAT score, so you can overshoot the range, that doesn't matter. So I'm going to say let's let the score from 0 to 1799 to become 0. And another group that I let 1800 to supposedly the maximum score, but I'll just put, for example, 3000. You can overshoot the range. So remember this dashed line in Stata is always from to. So from 8000 to 3000, now all this value will be recoded and to become 1. Okay, so this is another way you can actually create a dummy variable or binary variable. So if I click enter, 30 changes are made. So if you double check your data, our high score and our high score 2 are exactly the same. Sometimes there are always multiple methods to achieve the same result. So I just introduced 2 different comments. One is the generate with some longer complicated expression. The other one is generate and recode. This recode one is even better because it does not limit your recoded result to be only 0 and 1. You could recode, for example, now I'm going to generate a new variable that is SAT group. So actually what I'm doing here is I'm going to change, I can probably do, let me just do SAT. I can probably do age. In the exercise, you'll be working with age. So translating an age into 4 age groups. But here I'm going to do SAT into groups, maybe 3 groups, high score, medium score, and low score, right? So, but first I want to generate a new variable so that I don't replace the original one when I recode. So generate SAT group equals to SAT. And I'm going to recode SAT group. So I'm going to ask from 0 to maybe 1600 to be 1, group 1, or just 1. And I'm going to let 1601 to 1799 to equal to 2. And I'm going to let 1800 to the maximum, maybe 3,000. It's not 3,000. It equals to 3. So now I click enter. I actually recoded my continuous SAT score into 3 groups. Right? So now you can either, for example, you can still sum SAT group, right? So the mean is 2.33 something. You can still kind of interpret that. Alternatively, you can really treat SAT score into categorical variables, and you can tab SAT group. And actually you see that 20% of the individuals scored low, 26% scored average or medium, 53 scored high. But I just arbitrarily set the range. Of course, sometimes when we set income groups, age groups, we do want to be a little bit careful of our thresholds there. Okay, but that's the idea of Recode. The last one that I want to talk about is the Tabulate, which I just did. So we could also sometimes we just translated some quantitative variable into categorical variables. But now we could also translate some categorical variables into quantitative variables, but it's going to be binary variables. But the binary variables is 1 and 0, but we'll not be working with text anymore. We'll still be working with numbers, so that's a lot easier when we enter it into other equations, right? So for example, we have many qualitative data, student status or major or gender, right? So previously I introduced that you can tab gender, and we have 2 categories. But alternatively, if you tab and also use comma generate, and then you can provide any name that you'd like. Sometimes I will just use the same name because you're going to rename it very soon. Okay, let me show you how does it work. So now instead of just tab the gender, I give an additional option, which is comma generate gender. So if you do that, if you couple generate with tab, basically it will tab the gender 2 categories, and for each category it will create a binary variable for you. So now if I click enter, and you see I actually have 2 new variables generated. One is called gender 1, where gender is female. The other one is called gender 2, where gender is male. And how do I know these are binary variables? Take a look at the table. So gender 1, where if it's female, is 1. If it's male, is 0. Gender 2, if it's female, is 0. If it's male, is 1, right? So because the name that I have was called gender. So if the name is gender and it has 2 categories, it's always going to be gender 1, gender 2. And if I have, say, 3 variables, for example, let's tab major, generate major. I'm going to have 3 categories, and I'm going to have major 1, major 2, major 3. So click enter. I actually have 3 new binary variables, major 1, major 2, major 3. So later on, I can use these binary variables to see if there's a difference between male, or if there's a difference between female, or if there are differences between different majors. However, I just liked to use the same name to create the binary variables, but an important step later on for research purpose is always better to rename these variables, because no one knows what is major 1 or major 2 or major 3, although we have some labels here, but it's always better to rename the variable. So actually the next one, working with existing data. So whenever you load a new data and you want to rename the variable, or like what I did just now, I created some new variables where the Stata will by default create the variable 1, 2 or the variable 1, 2, 3. I can use the rename variable comment. And it's very easy, just rename the old variable with the new variable name. So for example, now I want to rename gender 1 to be female. Rename gender 2 to be male. Okay, so if I successfully renamed that, and if you go to the data plotter, one variable is called female, one variable is called male. So it's very easy to tell that 1 indicating a female, 0 indicating a male in this variable, and vice versa for the other. If the variable name is gender, you have to always report somewhere else what is 0 and what is 1. Because remember, for categorical variables, they do not have a naturally assigned numerical values. So we don't know what is 1, we don't know what is 0. Okay? Alternatively, sometimes if you forget this comment, actually one little thing or tip that I can show you, which you do not have to memorize this comment name, is usually we do have this property windows and it's usually locked, right? So sometimes if, say, I forgot what's the comment for the rename, I can just click, for example, click major. Right now it's locked, but if I just unlock that and I can change this major variable name into economics. Click enter and maybe lock it back again, right? Actually, then the comment will generate automatically by yourself because it will still show what you did. But this property window, sometimes you loaded a new data, maybe you can go over the variable name one by one, and you can unlock your property and rename each variable to however you want to work. So that will be very easy. So now I can rename major 2 to math, enter, and rename major 3 to politics, enter. And then I'm going to lock my property window. Okay. The last thing when it comes to working with existing data is basically the drop and keep comment. But you do want to be a little bit careful when you apply that because there's no way going back. So sometimes when you are dropping variables, but you may actually need it later on, probably you want to save your data set, and then you drop the variable and you save the data set as a different version and so on. But for exercise purpose, we do have many unused variables. So for example, we can just drop several variables. So you can either drop one variable or you can drop a list of variables. So for example, now I'm going to drop, for example, this one, high SAT. I just write drop high SAT. Click enter. That variable will be forever gone. It will not be here anymore. So this is where you want to drop one or multiple variables. You can use this comment. Okay. And keep, I don't really use keep. Keep is basically the opposite of drop. So instead of dropping a list of variables, if you only say, I only want to work with one variable, or 2 variables, I want to maybe drop all the rest. Maybe you have to, instead of dropping 60, 100 other variables for very large data set, you can use keep. So for example, you can say I'm only going to keep the variables from the original data set, which means that I have to delete all others. Then you can say I'm going to keep 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the 11 original variables. But if I do that, there's no way going back. Those variables I created but not saved, I have to recreate them again. But for practice, you should know how to create them if you accidentally dropped it or not keep it. Okay, so if I click enter, you see all the rest of the variables are gone. Okay. So instead of dropping a variable, sometimes you can also drop observations. This is where you use drop and keep comment with the if. So for example, if sometimes you want to work with only a data set where you only want to study individuals from the US, so you can do, say, for example, you can keep if country equals to US, or you can also say, I want to drop if country is not equals to US. The same thing. So let's try. So I can say drop. So basically, you are dropping observations. So now you are not dropping the columns of variables. Now you are dropping any observations. You are trying to find a subset here. If you are trying to drop any observations, all the variables for that observation will be gone. So you don't give the variable name. You only give the if comment. So drop if country is not US, and also US is a text, so not US. Country, not US. So 10 observations are deleted. So you only have those observations for a country. But this comment, basically, this is where you work with a data set and you also want to create several versions of sub data set. You can do that and resave and then later on work with the sub data set. But also because you have this if comment, so if you want to use sum, you want to work with a data set, you can basically always use the if comment. You don't have to actually delete that observation. But I think it's something that you should know. And the last one is, say you're done with the data set and you want to work with the next exercise. Instead of just close Stata, you can basically just use the clear. And this will clear all your variables. So when you use that, make sure you save them. And now maybe you can load a different data set and work on another data set. This is the last comment, clear.